This lesson is about finding the center and scale factor of a dilation. Let's talk about finding the scale factor. To find the scale factor of a dilation, you need to find the length of one of the sides of the preimage. If you don't have a vertical or horizontal side, for instance, if it's diagonal, you will have to use the distance formula in order to find the length. The second thing you'll do is find the length of the corresponding side of the image. And just like for the one on the pre-image, if it's not vertical or horizontal, you're going to have to use the distance formula. And then once you have those two lengths, you're going to divide the length of the side of the image by the length of the side of the pre-image. So it's image divided by pre-image. And then to find the center of a dilation, you draw a line through one of the vertices of the pre-image and its corresponding vertex of the image, and then repeat that step over and over again for all of the pairs of vertices, and the center is where the lines intersect. So let's look at example 1. Identify the center and scale factor of the dilation. We'll start out with the center. All right, in order to find the center, I'm going to draw a line that connects the two corresponding vertices. So let me do L and L prime to start out with. So when I draw a line that connects L and L prime, I end up with this line. I may need to do a little bit of readjusting in order to get it accurate. Okay, and then I'm going to do the same thing for M and M prime, readjusting as needed. And then I'm going to do the same thing for N and N prime, also readjusting as needed. And so with this, it's clear to see that the three lines converge at this point here, which is at 1, 2, 3, 4, 5, 1, 5. So the center is at the point 1, 5. All right, to find the scale factor, I need to find the length of one of the sides of the pre-image and the corresponding side of the image, and then divide the length of the image by the length of the pre-image. So let's just do, none of them are vertical or horizontal here, so I am going to have to use the distance formula. So I'm going to do LM and L prime M prime. So for LM, I first need to identify the coordinates, because again, I'm going to need to use the distance formula. For L, it's 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then for M, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to plug these numbers into the distance formula, which is the square root of y2 minus y1 squared plus x2 minus x1 squared. All right, so that's going to give me 11 minus 9 squared plus 5 minus 13 squared. 11 minus 9 is 2 squared, and then 5 minus 13 is 8 squared, negative 8 squared. 2 squared is 4, negative 8 squared is 64, so I get the square root of 68, which I can then just put into the calculator. Let's see what that is. All right, so it's not a perfect square, obviously, so you end up with a decimal. For now, let's just leave it at the square root of 68. I don't want to round anything and shave any part of the number off. So this is the square root of 68. All right, so now let's find the length of L prime M prime. So L prime is at 3, 1, 2, 3, 4, 5, 6, 7, 8. And then M prime is at 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so I'm going to have the square root of 8 minus 7 squared plus 3 minus 7 squared. 8 minus 7 is 1. 3 minus 7 is -4. 1 squared is 1. -4 squared is 16, so I end up with the square root of 17. All right, so the rule says that I'm going to divide the length of the side of the image by the length of the side of the preimage. So it's image divided by preimage. All right, for the image here, I know that L prime M prime is the image because it has those apostrophe symbols. So I'm going to have the square root of 17 over the square root of 68 for the preimage. So let's see what that equals. This is where I'll put it into the calculator. So I'm going to have the square root of 17 divided by the square root of 68, and that gives me 0.5. So the scale factor here is 0.5 or 1/2. Okay? All right, let's look at example number 2. Identify the center and scale factor of the dilation. So we'll start with center just like we did before. I'm going to connect the corresponding vertices. It's a little bit harder to do on an iPad, but I can kind of see where they're all going to converge right now. And that does indeed seem to be where they converge. So it's this point right here, which is the point -1, 2, 3, 4, 5, 6, 7, 8, 9, -2, -9, -2. So the center here is at -9, -2. All right, now for the scale factor. The good thing is that this one will be much easier because I have a pair of horizontal corresponding sides here and here. So the length of AB we can see is 3, and the length of A prime B prime is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, A prime B prime is the image, and remember it's the image divided by the preimage. So that's going to be 12 over 3 or 4 over 1, which is 4. So the center is -9, 2, and the scale factor here is 4. All right, examples 3 and 4 are more of the same, but I am going to cut it short just because I don't want to I don't want this to be too long.